You already know the basics of exponents. This is called expanded form when you write it out. Here's another one that we commonly forget. If you do not see an exponent, just like when you don't see a number in front of a variable, there's a 1. And so this is, if it's just 5, it's 5 to the first, because there's 1, 5. So there's some reminders for you. So let's talk about the multiplying rule. Here's the rule. I'm going to write it out with some weird letters first, and then we'll do an example. So say we have something A is the base, M is the power, times A to the N. So A to the M times A to the N. That is equal to, what do I do with my powers? If I have the same base and we're multiplying. Add them up. So it'd be A, and then you add these up to total them. Because it'd be having, how many A's total do you have? Add. Okay, so in words, you are going to keep the base the same, but you add the exponents. So that's your rule. If you have the same base and exponents, keep your base the same, add the exponents. Here's an example. You can come up with a different example if you want. I do not care. It's your notes. 2 to the third times 2 to the fifth. How many 2's total? 8. 8. And so the shortcut here is you can add the exponents. That would be 2 to the 3 plus 5, which is 2 to the 8th. So if you want to come up with your own example or use mine, it doesn't matter to me. So you're just totaling up how many do you have. We are going to do some examples of this. So let's move on to that section. Okay, slowly. 2 to the second times 2 to the third. Keep the base, add the exponents, or just think how many total do you have? How many? 5. So you write it as 2 to the fifth. Now, notice what it says. Simplify the expression. When I say to simplify, leave the exponent. If I ask you to evaluate, I'm asking you to go ahead and tell me what number that would be if you multiply 5 2's together. But I'm asking you to simplify, so leave it like that. Next one, W to the ninth, W to the second times W to the seventh. How many total do you have? 18. Is that right? Okay. Yeah, you add them up. 9 plus 2 is 11, plus 7 is 18, so W to the 18th. Ooh, I like this next one. 4 to the fourth times 4. How many 4's? This is 4 to the first. So in total there are 5. 4 to the fifth. Add your exponents. 4 plus 1 is 5. Last one, I like this too. When you have negatives, put them in parentheses. That's important because when you're multiplying negative times a negative, what happens? Positive. You'll see that happen on the back page. So negative 6, this is negative 6 to the first. So how many negative 6's total? 7. So write it like this. Negative 6 has to go in parentheses because you were saying it's negative 6 to the 7th. If you left that off and did it like this, negative 6 to the 7th, what you'd be saying to me is it's 6 to the 7th times negative 1. That's not what this is. We want it to be negative 6 to the 7th. So you have to put parentheses around negatives in these type of problems. Okay, next rule. I already showed you where it comes from. Power to a power. I'm going to do the first one with letters, and then we'll write it in words, and we'll do an example. A to the M to the nth. That kind of looks like an H. N. In words, keep the base. Notice I will say that every time because your base number, the big number, never changes. And what do we do with our exponents? Multiply. Because remember, we wrote it all out.
So if it's in a parentheses and like the ends on the outside, that means you multiply?
Yeah. So it's saying, do that thing however many times the outside exponent says, and then that has an expanded form like the one I showed you on the board. So an example of this could be 2 to the third to the second. That's 2 to the 3 times 2, which is 2 to the 6th. And you could write this out. That's 2 of these, and in each of those there's 3. We're going to do a few more examples. So when you're ready, you can flip it over. Power to a power. Keep the base, multiply the exponents. Okay, these first ones are pretty easy. 5 to the second to the third. Keep the base, multiply the exponents. It's 5 to the 6. Multiply your exponents. Multiply 2 times 3. You get 6. Sometimes I see students do this, where they just like you do when you distribute, they draw a line between them to tell them to multiply. Whatever works for you. Okay, B, n to the 7th to the 2nd. N to the 14, multiply. Multiplying these two. Now, again, it's important to keep your negatives in parentheses. It's negative 3 to the 5th, all that to the 3rd. Multiply your exponents, we get negative 3 to the... Thank you. So if it's in parentheses to start with, keep it that way, please. And here, the last one, you're going to keep this one in parentheses. Z minus 4. Multiply your exponents, it's Z minus 4 to the 10th. 2 times 5. That's not so bad. Okay, the last one is like power to a power on steroids, a little bit, okay? So you're just going to do power to a power twice. There's an example of it. If you have two things in the parentheses and power to a power, then you'll just multiply to both of them. It's easy to explain this with an example instead. So 4 has a power of what right now? If you don't see a number, what power does it have? 1. And 16 is also to the first power. So now you're going to multiply, because you're keeping the base and multiplying the exponents. 7 times 1 and 7 times 1. So it would be 4 to the 7th times 16 to the 7th. And if you want to keep it in parentheses, you can, but you're doing power to power, so it kind of comes out of the parentheses. Okay, so you're doing power to a power, just do it twice. Before you do that, make sure you know what the exponents are inside if it's not marked already. Okay, next one. Ooh. Okay, see that negative number? We need to make sure it's, because it's negative 3 to the 2nd. I'm going to rewrite this. I'm going to put brackets and then put negative 3 in parentheses. And then the rest of it can go like that. So if you see a negative number taken to a power, it's never a bad idea to put in parentheses. Look at all of these right now. You don't see an exponent. What exponent do they have? 1. In a second, they'll have an exponent of 2. So now we're going to multiply power to a power. Multiply all of those exponents by 2, and so it becomes negative 3 in parentheses squared times r squared times s squared. Okay. On all the rest of them, I've told you to leave the numbers like this. Make a note to yourself. If you have variables, like we do here, R and S, you're going to go ahead and evaluate the numbers.
What was evaluating?
Means that you're going to actually find out what they equal. So we know that negative 3 squared is the same thing as negative 3 times negative 3, which is what?
9.
Positive 9. So you would actually write your final answer as 9. Oh, hold on. There we go. 9r squared s squared. So if there's variables, go ahead and figure out what is that number. Okay, the last one. Oh, wait a second, sorry. Okay, last one. The negative is outside the parentheses, and so that's very different. That's saying do power to a power with those 3, r, and s, and then after you're done, multiply by negative 1. Just the, you'll see, you just have to do it once because these are all stuck together. So all of these have a power of 1. So order of operations says deal with your parentheses first. So we're going to deal with the parentheses and the exponents first before we deal with that negative. So that would become 3 squared times r squared times s squared. Still in the parentheses, because there's a negative outside of it. Okay, what is 3 squared? It's 3 times 3, which is 9. So now it's negative 9r squared s squared. And when you're multiplying by negative 1, it's not like you distribute to each term. We only distribute to each term when there's adding or subtracting in between. These are all multiplied together, so technically this is all one term. So you just write it as negative 9r squared s squared. You just put it out in front, you multiply to the number, and you're done. The first one's